So we went through a lot. We learned how Aera actually helps you make decisions. We talked a lot about agentic AI. Lots of demos, amazing, right? So now what I'm going to do in this session is I'll take you a little bit into core agentic decision intelligence capabilities of Aera. All right, I'll first introduce a little bit, and then I'll go into the demos and show you how agentic AI comes to life in Aera Decision Intelligence Platform. All right, so let's start. Aera Decision Cloud, and this is how agentic AI manifests itself in Aera. Agents, agent teams, agent functions, and multi-LLMs. Okay, what does that mean? So agents bring the intelligence, the autonomy. We'll talk about that a lot today, all right, the autonomy. Agent teams, it creates the canvas, the collection for the agents where they can talk to each other, collaborate, solve the complex decision intelligence problems. It helps create the hierarchy, different execution patterns, parallel processing, delegating the intelligence to each other. Agent functions, think of these are core building blocks that helps the platform access the data, that helps the core data processing, machine learning, optimization can be executed. And last but not least, supporting multiple types of large language models. You know, we have all sorts of them going on, many open source, cheap, fast models. The good thing is Aera supports connecting your choice of LLMs into Aera and work with them, craft your own intelligence in the platform. All right, so today the topic is about building faster with decision intelligence with agentic AI, right? Okay, so let's talk about that in 3 dimensions. What does that mean? What does that bring? It brings faster decisions with autonomous agent, with the plan, act, observe, replan loop, which I'm going to talk about later, and with self-learning, now you're able to achieve more, faster, easier. Faster to build, composability. It's basically you put together building blocks and you compose your intelligence and you deploy these agentic intelligence of Aera to tackle the most complex problems that you deal with in your lives, in your work. Time to value, significantly accelerated. And faster to scale. Now, with multi-agent teams, when you decompose the intelligence into small building blocks, and you build once and reuse, you can go faster. You can build faster, you can compartmentalize the intelligence into these Lego blocks. Now, we'll see everything that I'm going to show you today is live and production ready, right? So let's move on. I'll talk a little bit about a scenario. Everybody was talking about different business problems. I had to do it also, okay? Now, let's think about a scenario. Typical. Let's say on Friday afternoon, 4 p.m., you get this order. It's critically back-ordered, 5,000 pounds of pharmaceutical products, and you have a tight deadline, all right? And there is a high penalty if you, in your contract if you cannot make it. And you have a lot of different options, but if you think about it, what your team needs to deal with at that point in time, in 2 to 4 hours, they need to go through all these different options of regions, figure out the right combination of the routes. But the thing is, earlier you also used a solution where you had a hub, and then you actually temperature failure happened and you lost 42,000. You don't want to do that again. Now it's high stakes, tight deadlines, complex. How are you going to solve that? What if Aera already solves that? I receive this in my Aera inbox. It tells me You can transfer from Houston to Denver. It's already solved. Okay, how did that happen, right? And on top of that, it tells me, explains me its reasoning, what it did, what options it went through, and how did it leverage the historical data that we saw a failure earlier, how it actually acted upon that and learned from it, and then came up with a solution, not only satisfy all the pharmaceutical cold chain FDA requirements, but also learns from my past historical mistakes, right? Perfect. How do we do that? Very good problem for a very smart, intelligent agent. Let's talk about how we configure Aera's decision intelligence in order to tackle problems like that, okay? So what do you need? We talked about functions. What are they, right? So they help you access the data. They help you transform the data. They help you manipulate the data. But these are basic building blocks. You no longer program, hand code the reasoning. These are the hands and feet for the agents to actually massage the data. Okay, you need to check the inventory network, generate route options, calculate costs, query the historical patterns, validate, and generate a recommendation. But how do you ensure that actually it happens? You need validation. You need to check the work of this intelligent entity to actually do the right thing. Okay, then you configure some validation checks, some critic agents, check the cost, service levels, cold chain requirements, so on and so forth. So functions give agent the tools, and critics enforce the guardrails. We talked about guardrails. It's trust. Autonomous reasoning requires trust. It requires transparency. It requires guardrails. Good thing is, you can configure all that easily in Aera. All right. Then how does this reasoning come about, right? So what are we talking about? Everybody talked about agents today, but what is it? How does it happen? It manifests itself in an agentic loop. It executes in a loop until it solves the task. So you set up the goals. Remember the stage 3 that I talked about earlier in the session? Some people remembers, hopefully. All right, so you set the goals and agents do the work. Once you set the goals, this is what the agents do. They go through this agentic loop, plan, generate strategy alternatives, act, execute the functions, determine which functions, what kind of executions that it needs to do in which order, and gather the data, observe. Now in this case, it receives the outputs of those functions and then interprets them. That's your reasoning. When you get the inventory levels, when you get the cold chain requirements, agent interprets them to check whether the results are expected and determines what to do next. And then, if it requires, it replans, adjusts the strategy. And this loop continues until it's done. Stage 3, autonomous reasoning that adapts and acts. All right. Now, if you compare this to what you do normally in a deterministic modeling, in a deterministic development. So you go through all those steps, 8+ weeks of development. Usually what happens is this, and usually this is the case when our logic fails. It doesn't scale because there are so many unknown unknowns that you cannot hand code into your deterministic logic. That's where the large language models, the generative AI, the reasoning shines. What you do in the agentic development, on the other hand, you gather the requirements, you basically turn those requirements into prompts. So your requirements become goals to the agent. And what's left is just develop these basic tools, basic functions, and assign them to the agent so that it can actually access the data and then figure out where to get the data from, right? So what happens is significant reduction in development time, all right? And the key advantage is no more complex logic programming. You don't program. You prompt the agents. All right? So what happens with Aera is the autonomous agent comes out of the box. All you need to do is to configure it. So the loop I talked about is already there. The agent is already there. You can create as many as you want. You can connect whichever large language model you want. All you need to do is configure its prompts, right? On top of that, now, once you have many building blocks, you would want to orchestrate them. Remember, Professor Fuller talked about context engineering? Somebody remembers in the audience? Definitely. That's the new thing, right? Context engineering. So you gotta have to give the agents the right context so that they can reason over it. I mean, large language models are limited in their context length. You gotta have to give it the right amount of information, the right amount of data, so that it can solve the task efficiently. Now that requires an agentic design. So you gotta have to use agents to also create the right context for your autonomous agents. All right? So you use agentic AI for agentic AI. I'll tell you how you do that. Let's talk about a typical order fulfillment problem, okay? Now, in order to figure out how am I going to fulfill this order, I need information about my inventory, I need information about my customer service levels, customer priorities, I need information about my logistics. Each and every one of these are different areas, right? So what I can do is I can create agents that are specific for that function. They don't need to understand everything else. You compartmentalize the decision intelligence into that, and you create them. Now, for me to solve this task, I need all of this information. On top of that, if it's a pharmaceutical problem again, and if I need to do additional analysis on the logistics to validate them against, let's say, a cold chain requirements, now that I need the inventory and the logistic data, I can pass that data to the team that is specifically responsible for those requirements. Like, again, this is like a very specific area of business. Now, what happens is, with Aera, when you configure a team of agents, the orchestration is built in. Agents in Aera are orchestrated in parallel. You deploy the agents, they run all concurrently, unless you said otherwise, okay? So parallel programming made easy. You know how hard it is to coordinate distributed programming? This way, all you need to do is to define the dependencies among these data points, among these different teams of agents. In this case, inventory, customer, and logistics teams run in parallel while they feed into the cold chain team, and they all feed into this final decision synthesizer autonomous agent. It needs all the context to make the meta-level decision. Now, you context engineer into an autonomous agent, and you do that by deploying the agents and processing them in a distributed fashion without worrying about how to do it. That's the value proposition. Gives you the intelligent dependency management. All right, so let's see how we do all that.
So Mustafa, as you switch to the demo, I think there's a great opportunity here to back up for a second and just think about some of the concepts that we just walked through, right? So we talked about the agent functions, the agents, and the agent teams. Now, granted, I have a 5-year-old and 7-year-old at home, so I like to think about Lego building blocks. So your agent functions are those base level blocks, right? They're the hammers, the screwdrivers, things like that that are gonna do. Your agents are trying to accomplish a task using those blocks, and your teams are trying to create a higher order task. So when you showed that last example with the cold chain in particular, right, that was still a decision ecosystem. It was still a decision network. You can start to think about how you decompose that into how these different elements of that decision would come together. You then have the context engineering, right? So you have all the functions that are either remote functions or processes. So if you are an Aera customer and you're thinking about what about all those things that I've already built within the Aera Decision Cloud, these agents have access to those things as functions. So you can actually say, great, I want to call this particular skill or this particular process, in addition to going out there and getting that hammer or that screwdriver. So again, we go into the context engineering that you said from Joe Fuller, right? So then you're going in with the prompts and saying, now I have these tools, I have these processes, all these different things. How do I contextualize this with the critics, with the guardrails that you talked about? So it's really an organizing principle to be able to bring this new way to digitize decisions to life in the Aera Decision Cloud.
All right, thank you for that summary. Amazing, Joe. All right, so let's go into, we've seen a lot of Aera demos. I'm not gonna go into all the things that everybody has explained already. Right before me, you saw Lalita going through the workspaces. Now I'm gonna go into the workspaces, but focus only on the agentic AI area, all right? So that you'll see some stuff that you have already seen earlier. I'm not gonna talk about them. All right, now let's go take a look at the autonomous agent that I was talking about earlier. Let me make this a little bit bigger so that you can see it. All right, very good. So I talked about that you can configure your large language models. In this case, I'm using OpenAI model. Notice I chose the type of an agent autonomous, and I enabled planning. All right, so it starts with taking the order ID as its input, and then it generates a final response as a recommendation. Okay, so let's take a look at what happens. How do we get there? And I'll focus our attention into this task prompt, all right? I'll spend a little bit of time on this one because it's something that we need to understand a little bit. I'm not saying that this is the best way of prompting, but this is a way of prompting an autonomous agent. And here the difference is this. Remember, so I talked about the loop, agent loop, plan, act, observe, replan, right? So now all you need to do is to define its objective. So its objective is to generate an executive-ready transfer recommendation with route options, cost analysis, compliance validation, and confidence assessment. That's it. So you give its goal. The rest is all about setting some requirements, some constraints, success criteria. That's what we do, right? Joe, when we are defining the decision intelligence, defining requirements for a skill, we put together the success criteria. Remember I said you gather the requirements, turn those requirements into an autonomous agent prompt. You've already done that. All right, and then some things that we don't want our agent to miss never. Now, if we talked about agent functions, so in here, in this case, this agent has access to a function that gives it the availability of the inventory, all right? And then another function that gives us some route alternatives. So you need to, in this case, we're trying to solve this backorder situation, right? I need to figure out, okay, where can I move this inventory from? That's about it. Here's the killer, the historical pattern analyzer. So this one queries the DDM, brings about all those historical transfer information, and what happened? Remember the event that I talked about, that $42,000 loss? It picks that up, and then it determines not to use a hub route for this transfer decision. Although it's a feasible decision, it reasons not to use that because most of the data shows under these tight constraints for this product, for this backorder, it always fails. That's learning from your historical data, right in, right there. Very good, okay, then, but okay, how do I trust this thing? How do I know that it actually reasons correctly, right? So one thing I can do is I can configure its reasoning. I can put critics so that it interprets the data the way I want, the way how my business actually operates. For example, cost-risk trade-off. All right, so yes, there's a trade-off, but what it means within the context of my business. All I need to do is to craft that agent, give it the instructions of how it should actually interpret the cost and risk. And at every step of this autonomous agent, when it is reasoning about the data, okay, when it receives, remember the observe step in the loop, it runs these reasoning checks. Now, how do I control whether it's actually ran the correct functions? I insert some critics about validating the function results. These are my supply chain constraints. Whether the agent actually chose, remember, when it is running the functions, it's also generating the parameters. So you gotta have to control that. You have to check if the function was run correctly. And that's how you do it. As simple as that. And you test it. Starts running. Let me show you one that finished earlier. It gives you all the steps that happened. All the event history is available, and the logs. I'm not going to go into the details. I'm running out of time. So you can see every single detail of what actually happens at every step of every reasoning and every function call. All right? Let me just quickly go to the next one, where we remember the parallel sequential composite agent team with multiple agents and the autonomous agent that synthesizes the desired results. This is all you need to do. You define these agents, and then you define, in order to run this, what does it, in order to synthesize all the decisions, what dependency does it have? So in order for the synthesizer agent to run, it needs information from inventory analyst, customer analyst, logistics analyst, and the cold chain analyst. This is how you program the distributed parallel programming. That's all you need to do. You just find the dependencies. It's made easy. You put them into a team. The team, everybody in the team works together at the same time. You have the task. Unless you define a dependency, you have to first finish this for me to actually start working on it. You have to give me this data. That's all you need to say.
So Mustafa, when I think about sustaining a skill over time and the ongoing learnings that you have, because you're assigning these agents essentially as objects into this team, what would happen if I needed to make a change? So if I was going to go in and change one agent, would that all cascade into every team that is calling upon it later?
Yeah, amazing question. Exactly. So for example, in this case, inventory analyst, I might be using this in multiple different teams. Once I improve its prompts in here, all the improvements that has happened into this agent will propagate into all the other teams that it is being utilized at the same time. So you build once, you improve that, And that has a cascading effect of improvements into every other decision problem that you're solving. All right, so I'm cutting low in the time. Let's get back to the slides and then let me summarize what we've seen. All right, what you saw, building faster with agentic AI. Faster decisions, so we talked about the plan, act, observe, react loop. That's the typo there. We talked about self-correction. We talked about self-learning, self-correction, critics, correcting the job work of the agent if something goes wrong, and self-learning, acting on the historical observations. Faster to build, composability, build once, use in multiple places, compartmentalize the intelligence, create the experts, make one thing really good, and then reuse. No code configuration. I did not show you any code, so you saw the prompts. It's easy to configure them, given that you have all the required functions in order to access the data, and if you're already an Aera customer, as Joe said, you already have that. You have the processes, you have the data. All you need to do is to configure them into an autonomous agent if you want to deploy agentic AI. Otherwise, you build simple functions. Again, functions should not have the actual reasoning in them. You don't need to codify the reasoning into the function. Your functions, your data access does data access, brings the right context in a fast, efficient, and almost as needed as, no more than as needed, okay? They should do one thing and do perfectly. Faster to scale, again, build and deploy into multiple different agent teams, parallel executions, and synthesizing teams of agents that actually work together to solve the task. Autonomous, collaborative, fast to deploy, and production ready. I'll invite you to give it a shot, take a look at it, give it a try. You'll enjoy, you'll change how you think about your way of thinking about solving the decision problems will significantly change. Thank you.
Thank you, Mustafa.